So in this video, we are going to be reviewing Newton's laws of motion. So our objective with this quiz and video is to understand and apply Newton's laws of motion. So to quickly review, here are Newton's laws. So the first law being a body in motion remains in motion and a body at rest remains at rest until a force acts on it. The second law is that force is equal to mass times acceleration. And the third law is that for every action, there is always an equal and opposite reaction. Okay, so the first question here is asking us to consider if a stationary object has no forces acting on it. While this may initially seem to be true because the object is not moving, every object has acceleration due to gravity. For example, for this apple, it would be 9.81 meters per second squared. And there would be a normal reaction force as well. So while the apple is not moving, it does still have forces acting on it. So that makes this false. Now onto the second question. We're asked to find the magnitude of the force acting on this object. A couple reminders that force is equal to mass times acceleration, as stated by Newton's second law, and that the unit newtons, which all the answers are in, is equal to 1 kilogram meter per second squared. So we write out this equation, and we are given the mass. So we input 7 kilograms, and then we multiply that by the acceleration, which is 2 kilometers per second squared. Now something to note here is this is not the correct units to get us to newtons. So we have to do unit conversion in order to get a result that matches with our options here. So we multiply by 1,000 meters. So this is then equal to 14,000 newtons, which makes this the correct option. And finally, we're asked to consider this ball that is moving upward and to the left. We're also trying to figure out if the net forces are also acting that way. So this is a simple diagram showing one possibility of this scenario. However, there is more than one possibility. For example, another option could be that there's a reaction force that is actually causing this ball to move upward and to the left. Think, for example, a rocket ship. While the rocket ship is moving upwards, its net force is huge and downwards. So because of this, we don't really have enough information to be able to tell where the net forces are really going. So that makes this the third option. In summary, these are the questions and their answers.